And we're on. Hey, my name is Joe Arnold.
And I'm John Dickinson.
And we're from SwiftStack. I'm the president, one of the co-founders, John Dickinson.
Project technical lead for OpenStack Swift.
And we are introducing what we're calling Proxy FS, which is an integrated file system access into OpenStack Swift. And it's designed for supporting both object and file access with the same data, so in the same workflows.
So the reason we're doing this is because Swift has been enormously successful over the years, and we're growing with the number of deployments we have, we're growing with the number of contributors we have, the number of people who are contributing code, and the number of people who are using it every day. I've said many, many times over the years that my vision for Swift is that everybody will use Swift every day, whether they realize it or not, and we're seeing that happen.
And so at SwiftStack, we're focused on private deployments. And what we do as a company is we're the leading contributor to OpenStack Swift. And we've also built a commercial product around it to help our customers get up and running with an object storage system. And so we help out with all the provisioning and really focus in on the operations at scale so they can get up and running. And just some examples of customers, but there's also some additional needs that they need to have because object storage isn't necessarily in every single workflow. So we see things that are generating and a tremendous amount of data, and they support file system access natively to generate the data. Desktops, and we're all used to working with native file access. So object has been used more for building different types of applications, or where people doing our ingest, they're having to build additional tooling around that. And the focus of Proxy FS is to provide for object and file access so you can use the same workflow, the same set of tools, the same desktop workstations to access the same set of data.
So normally people have tried to solve this by saying, I'm going to stand up a file system gateway. But the difference is, with gateways, the whole idea is you've got some local cache, basically, of this remote cloud storage piece, which in a lot of cases can work well. Except, the thing is now we have the advantage of knowing that these workloads and these applications are all built to be this private deployments. They're not talking to this remote cloud storage. So we can actually take advantage of that and actually, because of that, overcome some of the disadvantages of gateways, which include having to have this local cache, this hard-to-scale, single point of failure sort of device. So if we integrate it directly into the storage system itself, the file system access, then we can give kind of the best of both worlds.
Yeah, because we have the data there, so might as well use it. So these are a few of the principles inside of Swift that we're using for persistence to build the file system access.
It's a highly durable system, it's highly available, and we have this property inside of Swift that if you create a new object, you're going to be able to read it right then.
So, the architecture. So we're creating Proxy FS as a parallel tier to the proxy access. And what the proxy does is the proxy routes requests to that storage tier. And Proxy FS will also use that object tier to store the bits of data that we need. Now,
so the advantages here are that we don't have any gateways and that we can treat everything as native objects inside of Swift exactly the way the storage is working today.
And because we have the read your creates, we can use a log structured method of storing the data. And so we're introducing log structured files inside of Swift.
The basic idea here is that you've got, every time you have a new write onto something, you're creating a new object inside of Swift. And then we create a manifest as part of the end of that on-disk format so that we can actually reference back to other things. And this means that if we have access to that latest object that's been created, then we can walk that manifest and figure out how to get the entirety of the contents just by following those manifests back.
So we keep track of that manifest, and it's very similar to how things like large object supports are already in Swift. But we're doing it in such a way where the manifest is much more fine-grained, and there's a structure to that, so we can efficiently, for file system access, go directly to where we're needed to service the file system requests.
And so actually we're doing the exact same thing with directories. So if you have files, that's great, but what you really need is a file system. You need to be able to tie these together to directories. So we're doing the same thing with that directory metadata, the listing, the permissions, all of the things you're used to keeping track of. We're storing those as log structured directories.
And so those log structured directories, in order to update them, you're just creating new segments into Swift as native objects. So that means when you have large directories, you don't need to rewrite a whole data structure in order to add a few files to that. You're appending to that log structured format. And the other thing it means is you don't necessarily need to roll up all the way up to the root node to support these large numbers of files that are in there.
So I think one of the great things I wanted to add on to that is that this means that you've got, again, to reemphasize, you've got native file system access to your objects and object access to your files. And these things, because they're all tightly integrated, not this gateway talking to remote storage, means that they can now work together. It's not, hey, Joe, stop working on the file system. I got to do some object API access, or the other way around.
Or I got to migrate data back and forth between the two.
It just means that I can, Joe can get a lease for a file in file system terminology. I can start using the object API, and Joe's client will automatically be alerted to that and realize that, no, we need to actually refresh this locally on the file system client.
So we can have coordinated access between the file and the object API access.
Yeah. So with this, with ProxyFS, the reason we really like this is because it gives you a bridge for the existing workflows and these huge workflows that you see that are requiring private storage today.
And we're seeing like people are wanting to build new applications supporting object. And I mean, we keep hearing it again, well, we want to move to object, we want to support object. The developers love object. But the reality is like object APIs are kind of like self-driving cars, right? They're coming and they're going to eventually be here, but it doesn't mean we're not going to all get driver's license, right? Sure, we're going to use object APIs to build the new set of applications for distribution, and developers love the self-provisioning nature of object API access, but now they can have access to the data that's coming in through file system workflows.
Back to what I said at the beginning, we want to lower the barriers for people to be able to start consuming Swift and taking advantage of scalable object storage systems.
And then the final thing is we're not trying to do something that isn't for what Swift is already great at, which is high concurrency, high throughput, durable, highly available workflows. So it's not trying to build a file system to, say, support running a virtual machine or running a database on. This is still trying to address the same workflows that object storage systems are great for today, but the applications don't yet support the object API.
Great. Thank you very much.
Any questions?